they restrict, or we restrict the domain from 0 to pi. So basically this part right here, if we were to draw a horizontal line through that, right, it would only intersect one time. And this is from where x is in between 0 and pi. So this is our restricted domain. From here to there. So the inverse cosine function, which is denoted by the cosine -1 to the -1 of x, or I guess we should write y equals the inverse cosine of x. This means the cosine of y equals x. So very similar to sine, except it's now cosine. Where y is in between 0 and pi. So this is for the inverse function now that we're talking about. And x is in between, or greater than or equal to -1 and less than or equal to 1. All right, so let's draw what these graphs now look like. Okay, so this is going to be our normal graph here. And here and here, here and here. So 1, 0, -1, pi over 2, pi. And we'll do this one later. Okay, so our restricted function, or the graph of our restricted function, is going to look like this, right? Because we have a point here, and a point here. So this is our graph of y equals cosine of x on the restricted function from 0 to pi. So our normal points are at 0, 1, right? That's this point. Pi over 2, 0, which is this point. And pi -1, which is this point. And we're going to do the same thing. We're going to reverse the order. So x becomes y and y becomes x to draw the graph of our new function. So that means our new function is going to have the points 1, 0, 0, pi over 2, and -1, pi. Okay, so that means that our y values are going to go, from 1 or -1 to 1. Our x values are going to go from -1 to 1. And then our y values are going to go like that. So we're going to have a point at -1 pi, which is up here. We're going to have a point at 0, pi over 2, which is here. And we're going to have a point at 1, 0. So our new graph looks like that. And that is the graph of the inverse cosine. Okay, and so we're going to do the same type of problems for finding the exact value of cosine. It is the exact same steps, except so I'll just rewrite. So So 1, you're going to let theta equals the inverse cosine of x. You're going to rewrite theta equals cosine, or the inverse cosine of x, as cosine theta equals x, where theta is greater than or equal to 0 and less than or equal to pi. And then use the unit circle to find the exact value, or you can use table 4.8. But you won't be able to use table 4.8 for your tests, so I recommend not using table 4.8 and getting used to using the unit circle in your brain. Okay, so let's look at the first example. This is example 3, but it's the first example for cosine. So find the exact value of the inverse cosine of negative root 3 over 2. We're doing the exact same steps here. So theta equals cosine negative 1 negative root 3 over 2. And then we rewrite this as cosine of theta equals negative root 3 over 2. Okay, now we're going to look at our unit circle and figure out where we're going to get negative root 3 over 2. But for cosine, instead of looking at this half, we're instead going to look at the top half of the circle from 0 to pi. So in order for it to be negative root 3 over 2, and it's probably going to have to be in quadrant 2, right? Because quadrant 1, they're all positive. Quadrant 2, some of them are negative. So cosine is your x value, negative root 3 over 2. Right here, negative root 3 over 2. This is 150 degrees if you go from 0 to here. But if you do 180 minus 150, you get 30. So this is a 30-degree angle we're working with. Or if we draw this, because this is in quadrant 2, so it looks like this. Cross from the 30, well, this is cosine, so this should be negative root 3. So the adjacent, remember cosine is adjacent over hypotenuse. So the adjacent of this angle is negative root 3 and the hypotenuse is 2, and that means this, so we're working with this should be 1 over here. We're working with a 30-degree angle in the second quadrant. So what is the 30-degree angle in the second quadrant? Well, looking back at our unit circle, it's 150 degrees, or 180 minus 30, which is 150. You don't want to write 30 because you're not going to get the right answer, because 30 is in quadrant 1, right? But this is in quadrant 2. So the angle that we are working with is 150 degrees, but we want to convert that to radians. So we multiply by pi over 180. And you end up getting 5 pi over 6. Or you look at your unit circle, 150 is 5 pi over 6. Okay, I want you to do checkpoint 3. And this is find the exact value of the inverse cosine of negative half. So pause the video, work it, and then come check your answer. All right, so theta equals the inverse cosine of negative half, and then we rewrite this. So cosine theta equals negative half. So remember, cosine is adjacent over hypotenuse. That means the triangle that we're working with adjacent to this angle is -1, and its hypotenuse has to be 2. So once again, we're working with an angle in quadrant 2. Adjacent to this angle, so this would be opposite, right? So adjacent is this one, so this is -1, 2, which means this one has to be √3. So what we're working with here is a 60-degree angle, but it's a 60-degree angle in quadrant 2. So 180 minus 60 is 120. So that's the real angle we're working with. So theta equals 120 degrees, and converting that to radians, we end up getting 2 pi over 3. And just to confirm that with our unit circle, 120 degrees, 2 pi over 3. All right, so the last little bit I want to go over is on the inverse tangent function. Okay, so the inverse tangent function. Okay, so let's draw what the normal function looks like. So pi over 2, pi, 3 pi over 2. This is negative pi over 2, negative pi, negative 3 pi over 2. For the normal tangent function, we know we have vertical asymptotes at negative pi over 2, and then at 3 pi over 2, negative 3 pi over 2. Right, so our graph looks like this. And this is the tangent function. Okay, so once again, we're gonna have to restrict this because if we draw a vertical line, it goes through a bunch of them. And they restrict this on the domain. Now it looks similar to sine, but they're gonna restrict it from negative pi over 2 to pi over 2, where x cannot equal negative pi over 2 or pi over 2. So y equals tangent of x, where x is greater than pi over 2. So notice it's not greater than or equal to, it's just greater than, and less than pi over 2. So thus, y equals the inverse tangent of x means tangent y equals x. Oops, where negative pi over 2 is less than y is less than, oops, I didn't mean to say less than. Y is greater than negative pi over 2 and less than pi over 2. All right, so if we were to draw this, what does this look like on the restricted domain? It's just gonna look like this part here. But let's draw what that looks like. 1, negative 1. Okay. We've got a point here, point here, point here. So our graph looks like that. So we've got points at negative pi over 4, negative 1, 0, 0, and pi over 4, 1. In order to get the graph of the inverse function, we have vertical asymptotes at here, and they're like normal. We're going to reverse the order of the x and y coordinates. So we're going to have negative 1, negative pi over 4, 0, 0, and 1 pi over 4. Oops, I forgot to draw the... So this is 1, 2, negative 1, negative 2. Okay, new points, negative 1, negative pi over 4. So here, 0, 0, and 1 pi over 4. It's here. So our new inverse, or y equals the inverse tangent of x is, it looks like this. And this is our normal. All right, so we're going to do the same type of problems for a tangent. We're going to find the exact values, except you can write theta equals the inverse tangent of x as tangent of x, or tangent of theta equals x, where tangent is restricted on the domain where theta is greater than negative pi over 2 and less than pi over 2. Okay, so let's do example 4. Find the exact value of the inverse tangent of root 3. Okay, well first we're gonna write theta equals the inverse tangent of root 3. And then we can rewrite this as tangent of theta equals root 3. Now remember that this is root 3 over 1, and that tangent means opposite over hypotenuse, right? Now with tangent, we're looking at we're trying to find the angle on the domain from negative pi over 2 to pi over 2. So here. Okay, so root 3 over 1. Well, that's probably related to either a 30-degree triangle or a 60-degree triangle. And it's got to be in quadrant 1 because it's positive. So tangent is opposite over hypotenuse. So the opposite is root 3. Oh, not hypotenuse, sorry. This should be adjacent. Opposite over adjacent. So this should be root 3, because this is our theta here. And this should be 1 here. So that means this has got to be 2. And we know that the angle that has its opposite being root 3 has to be 60. So this is a 60-degree angle, and since we're working with quadrant 1, it is 60 degrees. So changing that to radians, we get pi over 3. Okay, so that's it for the notes, but I do want to show you how this is done on a calculator. I want you to know how to do what we just did without a calculator first, but you know, I also want you to know how to do it on a calculator too. So, using a calculator, there are secondary keys, and basically if you look really close here, and this is kind of out of focus, it's not really getting any better. Okay, well, above your sign button is the inverse sign. Above your cosine button is the inverse cosine. Above your tangent button is the inverse tangent. So you can press the second button. So second. And that says inverse sine. So if I wanted to find the inverse sine of, I don't know, 1/4. It's that crazy decimal number. Now, there are a couple problems that I'm going to assign to you that want you to use a calculator, and they want you to round to 4 decimals. So let's do a couple of those problems really quick. So one of them says, well, we just did this one, the inverse sine of 1/4. So you'd use your calculator, do the inverse sine of 1 divided by 4, and you get that crazy decimal number. Now make sure that your calculator is in radian mode, because if it's in degree mode, you will not get the right answer. So you have to make sure it's in radian mode. So my calculator says this is 0.2527, and make sure you're rounding that last digit there. Okay, so let's try the inverse tangent of negative 9.65. Okay, so second, inverse tangent, negative 9.65, and I got negative 1.4675. Okay, so that's it. Your homework, which is going to be due Thursday, is page 547. Numbers 1 through 30 even. I will be grading these assignments that you're going to be sending me, and make sure you're sending them to my email. All right? So email me if you have any questions. I'll talk to you guys later.